There are three places to read and review the diagnostic report. On the left, you'll see that inside the 810 in the field, we can see the diagnostic report. The middle one is in the viewer software on your PC in your office. And then over on the right, the third is a PDF report from the viewer software also in your office. You'll see that the information is the same in all three, but it's easier to review the results in your office on a big monitor than out in the field on a small screen. Let's go over the individual steps of the diagnostic report. To read the report, first review the name of the machine and the locations measured and the faults found. You'll see the location of the fault, the severity, and then below that is the recommendation. Let's go over each one of the sections. In section A, we see the severity of the fault. In the chart below, we see the severity ranges are slight, moderate, serious, and extreme. Notice that over on the right, the severity scores, the recommendation, the priority, and description all track with the severity of the fault. Slight means we do nothing. Moderate means we see some wear, but we're not too concerned. We still have months to go before repair is needed. Serious means we should order parts and schedule repairs when convenient. And extreme means we're quickly running out of time. Based on the criticality of this machine, we should repair it immediately. In section B, we see the component on the machine with the fault, the motor, the pump, the fan, or the compressor. In section C, we see the fault found, imbalance, misalignment, roller bearings, or looseness. And in section D, we see the recommendation. Is it time to take the machine down for repair or wait a little bit longer? Next, let's look over the steps to validate the diagnostic engine results. We review the report. Do the faults and the severity make sense? If not, we might have bad setup or bad data. Then we're going to check the last page of the report. Is the machine set up correctly? Before that are the cited peaks. Does the pattern match the fault? And then we're going to scan the data. Does the data look valid? So let's go over these four steps. Step 1, review the setup. Was the machine set up correctly? If not, we can't trust the results. If it wasn't set up correctly, make changes and then measure the machine again. Step 2 is to validate the data. We can use these four images to show the obvious problems that can be found when scanning the data. On the upper left, we can clearly see the pattern of a healthy machine. Notice that the peaks line up with multiples of shaft rotation rate, and this is what we found in the baseline. Number 2, on the upper right, we see something that's different. If the machine is tested the wrong speed, the normalization speed routine will fail and the peaks will not be lined up with the baseline. We need to retake the data and make sure that we input the correct machine speed. On the lower left, we see something else that's different. If the sensor was not securely mounted during the machine test, the movement of the sensor will cause a lot of noise. We need to retake the data and make sure the sensor is securely mounted. And last, in the lower right, we see another pattern. If the sensor is mounted on a very hot bearing during the machine test, the temperature transient will overload the electronics in the sensor. This will result in a ski slope. We need to retake the data and let the sensor warm up before testing the machine. So, we've confirmed and validated the diagnostic results. We reviewed the report. It looks good because the setup and the data are good. We checked the machine setup details. The machine was set up correctly. We checked the cited peaks and the patterns match the fault. We scanned the data and the data looks valid. So now we can export the report to PDF, send it to the planner to generate a work order, and repair the machine.